Yeah, we're going to move on a little bit here with a new way to path deep brain imaging, and they have found a novel bioluminescence detection technique to image deep brain structures, circumventing the challenge of light scattering. This method involves engineering brain blood vessels to dilate in response to light, which can then be observed using MRI. By sensitizing the brain's vasculature to act as light detectors, the researchers effectively transform these blood vessels into three-dimensional cameras. These breakthroughs open up new possibilities for studying brain functions and mapping changes in gene expression with unprecedented detail. Key facts: bioluminescence as a tool. Typically used to track cellular processes, bioluminescence involves labeling cells with proteins like luciferase that emit light, enabling researchers to visualize biological phenomena. Innovative detection methods. The technique developed converts blood vessels into detectors of bioluminescence using MRI to image the dilations caused by light-responsive proteins, overcoming the issue of light scattering in deep tissues. Potential applications. The method could significantly enhance research capabilities in neurology, allowing for detailed mapping of gene expression and cellular interactions within the brain, potentially leading to advances in understanding neurological diseases and brain function. So, we talked about Neuralink at the beginning of this. I'm kind of like thinking, okay, there's a gamble going on right now, or a race, kind of both, a gamble and a race, of is biological changes by like bioengineering going to win this race, or is biomechanical engineering going to win this race of who can solve these issues faster, of issues with the brain such as paralysis or brain diseases or brain function, that sort of stuff, because both can solve it, right? But if you can solve an issue with bioengineering by just like changing stuff with your cells and not having some crazy machine put in your brain with wires, I can almost certainly bet that bioengineering is going to win in the long run over biomechanical engineering. Certainly. Biomechanical engineering will have some advantages over in some specific circumstances, but I can almost 100% tell you to hedge your bets on the bioengineering aspect, which is interesting. But so this is from MIT, and it says that a well-known problem that we face in neuroscience as well as other fields is that it's very difficult to use optical tools in deep tissue. One of the core objectives of our study was to come up with a way to image bioluminescent molecules in deep tissue with reasonably high resolution, says Alan Jassenhoff, a medical professor of biological engineering, brain and cognitive science, and nuclear science. The new technique developed by Jassenhoff and his colleagues could enable researchers to explore the inner workings of the brain in more detail than has previously been possible. Bioluminescent proteins are found in many organisms, including jellyfish and fireflies. Scientists use these proteins to label specific proteins or cells whose glow can be detected on a luminometer. One of the proteins often used for this purpose is luciferase, which comes in a variety of forms that glow in different colors. Jassenhoff's lab, which specializes in developing new ways to image the brain using MRI, wanted to detect luciferase deep within the brain. To achieve that, they came up with a method for transforming the blood vessels of the brain into light detectors. A popular form of MRI works by imaging changes in blood flow in the brain. So the researchers engineered the blood vessels themselves to respond to light by dilating. The blood vessels are a dominant source of image contrast in functional MRI and other non-invasive image techniques. So we thought that we can convert the intrinsic ability of these techniques to image blood vessels into a means for imaging light. By photosynthesizing photosynthesizing the blood vessels themselves. To make the blood vessels sensitive to light, the researchers engineered them to express a bacterial protein called Bagiota photoactivated adenyl cyclase, BPAC. When exposed to light, this enzyme produces a molecule called CAMP, which causes blood vessels to dilate. When blood vessels dilate, it alters the balance of oxygenated and deoxygenated hemoglobin, which have different magnetic properties. This shift in magnetic property can be detected by the MRI. So once again, we're talking about magnetism within the blood being used to image and measure different stuff. And kind of circle back to the whole consciousness thing being like based on magnetism. That's super weird. At what point does our bloods like have consciousness at that point if it's connected to our magnetic field? It's just a thought. I have no idea, but BPAC responds specifically to blue light, which has a short wavelength, so it detects light generated within close range. The researchers used a viral vector to deliver the gene for BPAC specifically to smooth muscle cells that make up blood vessels. When this vector was injected into rats, blood vessels throughout a large area of the brain became light sensitive. Blood vessels form a network in the brain that is extremely dense. Every cell in the brain is within a couple dozen microns of a blood vessel. The way I like to describe our approach is that we essentially turn the vasculature of the brain into a three-dimensional camera. And that's pretty much like the end of the article. There's a little bit more, and I can post it if you want to read the rest of it. But we're going to move on to something that's pretty cool, and there's some video that's just coming out. It's been around for a little bit, this engine that we're about to talk about, but I had not heard of this specific one, so that's why I was impressed by it. But so this is talking about a water-powered engine that's on the move for the first time in history, breaks power records, and is better than hydrogen. So what could this be? And it's a big old engine, if you can see this picture here. So it says, excluding conventional hydrogen in an energy transition context is challenging, but there's a water-powered engine that has achieved it, at least partially. It sets power records. The car with 2 hydrogen engines was surprising, but what's coming next is equally remarkable. In the context of decarbonizing the economy we're going through, hydrogen has become a resounding protagonist. The production of hydrogen for energy purposes is a topic of global interest. In fact, in recent years, there's been much talk about green hydrogen as a strong energy bet. Investment in this production is increasing globally. In the case of Spain, for example, they account for 20% of the world's new hydrogen project in the first quarter of 2022. And here it says, the water engine, a record no one expected but everyone wants. In fact, it doesn't entirely reject hydrogen, but rather uses it to its advantage. The Austrian company AVL Racetech has developed a powerful hydrogen combustion engine, an invention that demonstrates that this type of model can boast great performance and be used as an alternative to electric vehicles. Furthermore, it has the potential to be used in racing cars. It has emerged as a result of the collaboration of engineers from AVL Racetech and the Humda laboratory in Hungary. Its innovative hydrogen combustion engine has a novelty that makes it special, a water injection system. With this addition, the power problem traditionally linked to these types of engine is solved. How does the water engine that revolutionizes the hydrogen market work? Port fuel injection, or PFI, inserts traditional water into the engine's air intake system, preventing premature ignition that could damage the component, and achieves stoichiometric combustion. Translated, this means that the resulting air-fuel ratios are more or less fixed. This, according to the company, highlights the potential disadvantage of lean-burning engines. The result of this exhaustive work has been a 2-liter hydrogen engine that produces 410 horsepower and 500 newton meters squared of torque between 3,000 and 400 revolutions per minute, achieving a specific power density of approximately 205 horsepower per liter. Based on real tests, AVL guarantees that the engine will be able to compete in high-level motor racing. The results obtained by H2 Racing Engine confirm that we are able to offer an extremely competitive package with this technology. She also warns the company's goal is for motorsport to embrace sustainability. Can hydrogen be used for racing cars? This water engine could be the way. Hydrogen combustion engines serve for much more than just racing. They can also help smooth the transition to zero-emission vehicles. In this way, the simplest and most abundant chemical element on Earth takes another step into the automotive world. Those who have always believed the potential in hydrogen see in the water engine the symbol of victory. It displaces the conception of hydrogen vehicles that we had now. If you are fascinated by the potential of hydrogen, you can't miss what's happening on the highways. The first hydrogen highways are coming. So we'll definitely have to talk about that coming up. And still working on the hydrogen project. And we have to talk about the pyrolysis. Actually, I'm just going to talk about it right now before I forget about it. So there's a guy on YouTube named Nature Jab, and I'll link him in the bio too. I've been looking at him for a long time. He's a big inspiration of mine. It took a long time for me to find him. I kept on seeing all these TikTok and Instagram videos and YouTube videos that people had sent me of seeing this kid making biopyrolysis reactors of, well, I guess it wasn't bio because it wasn't plant matter, but you can use plant matter. But he was using a plastic pyrolysis reactor where you just melt plastic down and return it back into petroleum, like its base elements. And yeah, I mean, he's young and he's doing some like amazing work. This is literally groundbreaking work. None of the scientists will work on this sort of stuff because they're scared and they don't get paid enough to, and it's all about the money, and fear basically is what's keeping these technologies back. But this kid doesn't have a need for any of those things, so he's just going for it. Well, unfortunately, there was a accident with his reactor and he survived. But if you could donate any money for his PPE, the personal protection equipment, so that he will not get hurt again doing these experiments, that would be fantastic. Or any donations for his medical bills. He has videos of him afterwards. He has pretty severe burns on his legs, but I think that he will hopefully be okay. And yeah, he's going to need protective equipment if he ever goes back into this, and he said that he's going to. So yeah, hopefully you guys have even like $1 or $2 to spare for him and protective equipment or medical bills. You can pick which one you want to donate to, but I will put his information in the bio at the very top. And his name is Nature Jab if you want to check out his YouTube videos. He has a bunch. It's crazy. He's very, very inspiring. So we'll move on to the rescue here at the end. This one has a little 90-second video. Might as well play so that people can hear that. Here we go.
A young man was saved at Arcadia Lake over the weekend after 2 teenage girls jumped into action.
It's unbelievable. News 4's Hunter Lee spoke with them today about their brave efforts and their message to others out on that water.
The 2 teenagers shocked no one else stepped in quickly to help in the water rescue of a 17-year-old Friday afternoon.
Nobody helped us because there was tons of adults out there. We're just 2 girls trying to keep him, afloat.
A hot Friday afternoon in the sun took a turn when Kenzie Banner and Brianna Alston heard someone needing help.
Not even about 10 minutes after we had gotten to the water, we had heard a young man screaming, help. He was like frantic.
That's when they jumped into action.
That's when one of our friends like threw a floaty so that we could, keep him afloat.
The two finally got the young man back to land.
I'm glad that we were able to get to him in time before he actually went underwater.
Two teenage heroes needing help from others, but say no one stepped up to the plate until a retired lifeguard ran over.
So she started asking him questions, and then that's when another man came, but still nobody had called 911 or anything. So I was yelling like, call 911, he needs help, call 911. Nobody had called 911.
Edmond police at the lake confirm a call was made around 4:30. They say the teen was sent in an ambulance to the hospital.
I can't even imagine how scary that was for him too. Must have been so scary.
The two heroes now want to remind others before going out on the water.
Always make sure, there's people around that you can trust, or maybe even somebody that could help if something went down.
At Arcadia Lake, Hunter Elise, Oklahoma's News 4.
So yeah, that was kind of interesting to listen to, kind of tough to listen to, but interesting as well that, these kids were the ones that jumped in and saved the other kid while all the adults were just sitting there and didn't do anything. And even whenever they were asking for help, none of the adults did anything except for one lifeguard, like towards the end, probably whenever they saw it happening or whatever. So I don't know. I have faith in today's youth, and I think that a lot of people can take some solace in the fact that our youth kind of some of them have their head on straight. I mean, these people were really smart acting, quick thinking, and throwing him the floaty. That was really smart. If you're ever in a situation where you have somebody drowning, you're really risking yourself by going out and helping them. Depending on how panicked they are, they could try to jump on top of you to stay afloat and end up pretty much drowning you while panicking. And that is something that they teach you for like any basic lifeguard type of thing. You always throw a floaty to somebody, try to get a flotational equipment, because they will latch onto that. Whatever comes their way, they're going to latch onto and get on top of. And it's either going to be you or the floaty. So just remember that you got to have a floaty thing if you're trying to rescue somebody who's drowning. And they did that, and they fixed him up. It sounds like he was able to go to the hospital. Near drownings are pretty serious because you can have secondary complications and stuff, as far as I know. So it's good if he was really having a drowning event that he went to the hospital to make sure he doesn't have a bunch of liquid in his lungs or something like that. But the adults, it's hard to even know what to say whenever you have a crowd full of adults and only the kids are able to actually work in an emergency situation. I feel like the adults have gone astray a little bit, and that our kids are the ones like with a better head on their shoulders. So I don't know, that's kind of like good news and like kind of tough news at the same time. But I think no matter what, there's good people out there, even if it's a kid or an adult, it doesn't matter. There's good people out there. And even with a beach full of people that didn't jump in, there was at least two people actually, that went in and helped them. So I'm very glad that they were rescued. And I also thought it was interesting when she said, go swimming with people that you trust. That was like a really heavy statement. Very interesting. So yeah, words of wisdom to live by. And I hope that you guys are going to be safe. Look forward to another one. And hopefully we'll have some more out very soon. I have some stuff about Tesla that I'm going to release. An episode about Tesla that should be good. All right, we'll look forward to that.
Like a soldier one stop.